Hi everybody, Mr. Rubo here, and today we are looking at determining a degree of a polynomial just given just given a table of values. So there's two things we look at. So first thing, if we're given a table of values, it has to have equal length input intervals, and we'll talk about what that is in a second when we get to the example. And then if we have that, we can then determine the degree of the polynomial by examining successive differences that's a V in the output values. The number of successive differences needed for the differences to be constant is equal to the degree n of the polynomial. So it seems like a lot. Let's go ahead to these examples and you'll see it's really not too bad. All right, so the first thing we have to check is that these input values go up by the same amount. So plus 2, plus 2, plus 2, plus 2. So that is a check for the equal length input intervals for the first one. And the second one we have going up by 3s. So also check. Input values, input intervals, are equal length. So we're good there. So now what we're going to do is we're going to kind of do the same thing with the outputs, but we have to keep doing it until we get a constant difference. Okay, so here from -2 to -3, we subtract 1. Here we're adding 2. From -3 to -1. -1 to 4 is adding 5, and 4 to 12 is adding 8. Well, those are not the same, but we would call this our first difference. Not the same. So now let's go to our second differences, which is you take those same number, or the new numbers that you just came up with, and you see how far apart they are. So from -1 to 2, well, that's adding 3. From 2 to 5, that's adding 3. From 5 to 8, that is also adding 3, which that is constant, and this was our second one, which means that this is a degree 2 polynomial. Okay, so let's go ahead and do similar work on the next one just to kind of see this, and then we'll see how we actually write our answer in a second for both of these. So -2 to 0, that's adding 2. 0 to 10 is adding 10. That's adding 17 from 10 to 27, and that's adding 23. So it's not a linear function. Good, because that'd be boring for this video. All right, we go to the next one. All right, that's +8. That's +7. That's +6. Ooh, not quite there for our second, but we still need to do all those numbers to see when they do start being the same. And look at this one. That's +1. That's +1. From 8 to 7 is 1. From 7 to 6 is also 1. Ooh, I'm just kidding. It's not +1. It's -1. But the important thing here is that that's constant at the third successive difference, which means this one is a third degree. So as far as the answers go, the way you would write them, and I have them typed up right here. Control Z. Oh no, there we go. There we go. So for the first one, we want to say degree 2, since the number of successive differences for it to be constant for equal length input values is 2. And then you'll notice almost the exact same thing for the second one. It's just degree 3, and it's the same number of successive differences for it to be constant for equal length input values is 3. Okay, so there you go. Thanks for watching, and have a great day.